So now we had a long talk about simple linear regression analysis in detail. This time we're going to do a full linear regression analysis in one go. So let's have this problem. Armand's pizza business managers have observed that their most successful branches are those near populated colleges. Thus, they have gathered data on quarterly sales and student population of neighboring college. Perform a full regression analysis on the relationship of quarterly sales and student population of neighboring colleges. So we have the student population in thousands. So this 2 actually means 2,000, 6 means 6,000, and so on. And quarterly sales, 58 means 58,000, 105 means 105,000, and so on. So we are asked to perform a full regression analysis on this one. The first thing to do is to determine which one is our independent and dependent variable. So we have a clue that these two are our variables, but which one is independent and which one is dependent? Now, let's think about it. Will your student population increase as your quarter sales increase? Or will the quarter sales increase as student population increases theoretically? Common sense tells us that this is the one that affects this one, that as more of this, more of this. Not that as more of quarter sales, more of student population. It's that more of student population that affects quarterly sales. So that's why we will mark this as our X, our independent variable, and our Y, our dependent variable. So now we shall now do our steps in the full simple linear regression. When the first one is a scatter plot. So to perform a scatter plot, we go to insert. Then we select first our data. I forgot about that. So we select our data here. Then we now go to charts. We select this one. And there you go. We have our quarterly sales here. Maybe I will just put the name here on our x-axis. Maybe we can have access here, access titles. So let me just change this to, this is actually student population, and this is actually quarterly sales. So let me just put it like that. So as we can see, we have a pattern that it goes up from left to right. So now that we know that, we can now put our regression line. So we click this one. We again go to trend line here and we click that one. And as you can see, we already have our trend line. Let me just change what it looks like. Alright, there we go. And then with our trend line options, we can already input our equation. There we go. And actually, we can already show our R squared. So let's select again that line, trend line options, and we can actually now show our R squared. And maybe we can just make that big. There we go. So we already have our equation of regression, our regression equation, and our R squared. So just to write it in a more statistical way, we can say that estimated sales is actually equal to 5 times student population plus 60. So this is what our regression equation is, and that is represented visually by our regression line. So now we actually have our R squared that we can interpret later. We shall now calculate our Pearson R. So again, we go to data analysis. We choose correlation. Then we click OK. And you know the drill. Once you see this one, you select that. We select our data. There we go. Then once we click that again, we labels at our first row, output range. We just select here. Then once we select that, we click OK. And we have our data here. Let me just fix our writings. So there we go. So we have our R value of 0.95 and our R squared value of 0.9027. So to interpret that, we have our R equals 0.95. There you go. And our R squared is actually 90.27% or 0.9027. And if we're going to look back at our table for a while, we can actually see in our table that 0.95 is here. It has a very high correlation. So the strength is very high. So now we can say that there is a positive because the sign is not negative here. There's a positive and a very high or a very high or a very strong or very high relationship between student population and quarterly sales. We interpreted R, so our R squared now would be that 90.27% of the variation on the quarterly sales is due to the student population. So we can say that the strength is very strong. The question is this significant? So we now go to our hypothesis test, which is hypothesis test. So our step 1, as we know, we will just state that whether our beta, here it's 5, is that significantly different from 0 or not. Oh, not sub-0, but sub-1 rather. Sorry, let me correct that. There we go. And now we shall do our hypothesis test in Excel. So let me just hide all the scribbles here. So again, we go to data analysis. We now go to regression. And as you can see here, first we shall select our Y. Then we shall select our X. Here you go. And then labels. And then just the output range. Let's put the output range here. And we click OK. So here we are. So now we have the different values that we would need. And now we shall go to step 4. So here we have our steps 2 and 3 already. And we will now go, let's just label this steps 2 and 3. And now for step 4, we shall look at our p-value here, which is actually, if I'm going to select that, you can see that the value here is actually 0.00002. And when we round it off to 2 decimal places, that is actually already very close to 0. And that is very small than compared to our alpha, our default alpha of 0.05 since nothing is stated. Therefore, we shall reject HO. So we have, I will just make it short, we would have a significant relationship between the student population and the quarterly sales. So that's how we do a full-blown simple linear regression analysis.